Now we will learn how to find the product and quotient of a complex number in polar form. Look, let's see two given equations. They are in polar form. These are two complex numbers, z1, z2. Over here in the first case, z1 is having radius r1 of cos theta 1 plus I sine theta 2. In the second case, the subscripts, you can see the subscript, the numbers are all 2 because it's z2. For the product, it's very simple. You must remember product denotes to addition of angles and multiplying. That's it. Z1 and Z2 will be multiply the radii, and for the angle cos theta 1 and theta 2 is added. Same thing, I sine theta 1 and theta 2 is added. Whereas for the quotient, it's division, right? Z1 divided by Z2, divide the radii, R1 divided by R2, but the angles are subtracted, cos of theta 1 minus theta 2, plus I sine theta 1 minus theta 2. Let us look into problems. You will understand how we can solve this practically. Now here, find the product of these both complex numbers which are in polar form, then express the product in rectangular form. So after you find the answer, it's not over, you need to convert it to rectangular form. Let's see. First, use the formula, that is R1, R2. Over here, R1 is 2 multiplied by 4, cos theta 1 is 5 pi by 3 plus pi by 6. Then plus I sine 5 pi by 3 plus pi by 6. You can't do it entirely. All you need to do is, you need to do it by parts. So 4 twos are 8. It's very simple. You can do it. Now, what about this? It is cos. Okay, it's not done over here by cos, so it's done individually. What they are doing is 5 pi by 3 plus pi by 6. That is shift pi by 6. Now it's 11 pi by 6. So this is in the numerator the pi, so 11 pi by 6. Same thing over here, it'll be pi by 6. Now what you can do is, this is it. This is the answer for the polar form. We found the product, but it's not over in this case. You need to find the rectangular form. How do we do it? It's very simple. Just solve it up now. Use cos. We know the answer is simplified, but I've written the entire thing. What's the answer for cos? It's root 3 by 2. Okay. What about sine? Shift change to sine. It is negative half. So this minus half. Now multiply this 8 inside. Over here, when you multiply the 8, 2 ones are 4s are. So it's 4 root 3 minus 4i. This is the rectangular form. So the polar form of the product is over here. The rectangular form is over here. So these are the answers. Let's see a quotient problem. The product is simple. Now over here, it's a real world problem. If a circuit has a voltage E of 150 volts and an impedance, now you might have come across this impedance in physics already. Impedance means resistance. Impedance Z of 6 minus 3J ohms. Ohms is the unit of resistance. Find the current I in amps in the circuit in rectangular form. Use E equals I into Z. So they have told us the voltage is given, current times resistance, that will be the voltage. So we have to find, the formula is given. What do we have to find over here? They have told to find the current. Okay, what is the other way to find current? So voltage is the current flow multiplied by the resistance, that's the voltage, right? Now, what is the current then? It is the voltage divided by resistance, E by R, or in this case E by Z. So this is equal to I. So basically what you have to do is you need to find the division quotient of E and Z. That is what is required. So over here, write the given. So okay, now when we are writing, see this ohms, that's the resistance, is given properly in the complex form. But what about this? There is no imaginary part. The voltage is only 150. There is no imaginary part. That means the imaginary part is 0. So this can be even given as I. In this case, it's j. It's fine. 150 plus 0j. Over here, z is 6 minus 3j. So this is the thing. Okay. If it was the argon plane, then 150 voltage and 0 somewhere over here at 150x. Only this is the graph. Okay. Whereas over here in this case, we had 6 somewhere over here, minus 3, it would be like this. This would be the point. Okay. The y-axis, the imaginary axis, in this case, it's 0. Okay. Now then, what is I? We just now saw I is E by Z, E by R, resistance. It's one and the same. Now let us solve this. So first let's express this in polar form. Okay. So what do we do? For E, you need to find the resistance R, it's the radius. That's find the modulus and the argument angle theta. So R is what? A and B, square root of 150 plus 0 square, because there's nothing, it'll be the same. And the angle is, see, this is positive, isn't it? A value is positive. So this is it. This is the formula. Tan inverse of 0 by 150. Put it in the calculator, you'll get the answer. We have done this already before. Now, what about for? Okay, this is the polar form now. This is the polar form, 150 cos 0 plus j sine 0. Now, for Z, that is the impedance or the resistance, R is square root of 6 square plus negative 3 the whole square. The value is 3 root 5. Theta is, again, the A value is positive. So this is the formula. Put it in the calculator directly over here. Let me just do this. Shift tan inverse minus 3 divided by 6. What is the answer? Over here, it's negative 0.46. Remember, your calculator must be in radians. Only then you'll get the correct answer. Next, write it in the polar form. That is the radius cos theta plus I, or now in this case it's j. That's the imaginary part, j sine theta. Okay, what next? Now we need to find the division between E and Z, right? Let's do that. So divide them. 150 is the R1, 3 root 5 is the R2. So now let's divide them. Use the formula and divide it. So all you need to do is 150 by 3 root 5. And over here the angles are subtracted. Theta 1 is 0 degrees. Minus of negative 0.46. Same thing in both the cases. The answer over here, I, is so much. Now, how did we get it? Very simple. This is 150 divided by 3 root 5. You'll get the answer 10 root 5. That's equivalent to 2.36. And this, you're just multiplying the signs. That's it. Now, we will write it in the rectangular form because they have asked in the rectangular form, right? They're not asked in polar form. So all you need to do is, multiply this inside. This first let's solve. Cos 0.46. Close the bracket. The answer is 0.89 over here. It's equivalent to 0.9. And what about sine? Change this to sine. You will get the answer of 0.44. Now you need to multiply this inside. 10 root 5, multiply it over here. See, all you're doing is, this is multiplied by 10 root 5. The answer in this case is, I have taken the entire thing. If I just take 0.44, it'll be a little different. It's almost approximately the same thing. See, it's 9.84. Okay. Why? Because only 0.44 is taken to multiply with 10 root 5. Same thing, multiply over here. 0.9 times 10 will be 9 root 5. This is the rectangular form. So the current is about 9 root 5 minus 9.84 J amps. So this is the answer. Not in the rectangular form. You need to convert back to not in the polar form. You need to convert it back to rectangular form and then get the answer.